let's go back and read example 1 and see what this question is asking. It says, what dimensions will produce a box of maximum volume? Well, up until this point, we've actually just figured out x. Okay, we said that if the base is 6, then that will produce a maximum volume. But that doesn't tell us what h is, right? We want to know the dimensions of the box, so we have to figure out h. Well, fortunately, that's going to occur in our constraint equation. We plug in 6 for x, so we can solve for h. So for step 8, we want to determine additional information to answer the question. In this case, we want to know all the dimensions. So we're going to plug in, okay, I guess I did a different way. All right, since we already know what the volume is, since we solved for that in step 7, we can figure out h that way. But I will say you can use a constraint equation and get the same exact answer back. So we can use the optimization equation, plug in 108 for v, since that's what we got for step 7, and then plug in 6 for x. So v equals x squared h. 108 equals 6 squared times h. Again, we're just using the optimization equation to solve for h. We could have used the constraint, got the same answer. Okay, so 108 equals 36h basically, divided by 36, h equals 3. So that will give us our dimensions. We know that x is going to be equal to 6 and h is going to be equal to 3. That will give us x is 6 and h is 3 will give us a maximum volume. Our last step will be to answer it as a sentence, which we will do next in the next video. So for example 2 though, we're going to do step 8 as well. Let's read the question. Again, it says find the dimensions. Up until this point, we have only figured out x. Okay, we figured out that if x is 1.883, we'll get a minimum area. So now we need to figure out y. Now in this case, I did use my constraint equation. 3x plus 4y equals 10, so I can plug in this long decimal in for x, and then I subtract that number from 10 divided by 4, we get y equals 1.087411. So that means that our y will be a little bit bigger than 1, and our x will be 1.883, and that will ensure a minimum area given 10 inches of material. So again, you want to just, for step 8, you want to determine additional information to make sure you answer the question completely. In this case, the dimensions, both x and y. Okay, so going to our example 3 of rent and maximizing that. Read the question. It says, what rent maximizes monthly profit? Well, fortunately for this one, we don't need to determine any additional information because for step 7, we answered the fact that 1,160 will give us a maximum profit. So step 8 is good for example 3. All right, we will do one more video where we will answer these questions verbally, and we'll finish up our first 3 optimization examples.